we'll be going through your experimental answering techniques. So what exactly is this booklet about? So this booklet is basically a summary of all the various types of questions related to experimental questions. So if you were to realize in primary 5, you have a lot of questions that are based in the form of experiments. So they'll give you some experiments, and then from there, they will then query you on certain concepts. So we're going to look at the different types. All right? So basically, this is the scientific method, all right, which tells you that you want to actually ask a question and then state a hypothesis. So what is a hypothesis? A hypothesis is basically, I won't say it's like a theory based on your own scientific knowledge. So for example, you want to ask this question: do plants require sunlight to photosynthesize? And then based on your scientific knowledge, you would state that plants require sunlight to photosynthesize. Why? Because based on your theoretical knowledge, you would already have known that in order to photosynthesize, in the word equation, light is one of the components. So based on that, you hypothesize that light is necessary. And then you formulate an experiment to prove whether or not your hypothesis is true or false. So if under sunlight, okay, if under no sunlight, your plant is unable to have starch, but under sunlight it has starch. This would prove that your hypothesis is correct. Okay? So from the experiment, you will analyze the results. You will make a conclusion. Now, if your conclusion is not correct, you will go back to step 1, to the same question, and then maybe you formulate another hypothesis to explain the question until you finally get an answer that is of satisfaction. Okay? Now, these are the various types of questions that are related to experimental questions. So you have what is the aim of the experiment, how to make your results reliable, relationship questions, conclusion questions, fair tests, experimental and setup, hypotheses, generating possibilities, as well as accuracy. So in this whole entire lesson, I will actually tell you what are the key things to note for these various types of questions. And you need to be able to identify which question in your exam belongs to under which category, because they each have a certain way of answering. Okay? So the first one we want to talk about is the aim of the experiment. So there is a framework to answer. The first thing you would say is to find out if the change variable affects the measured variable. This is the aim. So what it means is that if they ask you what's the aim, you will always start with to find out. And then you go on to name the change variable and the measured variable. So of course the first thing we then need to know is what exactly is the change variable. So the change variable, can only be one, and you get to decide. You are able to change it, and that should be the only variable that changes. Okay? You have control over it. So what do I mean by that? So for example, in my aim is to find out if drinking milk will make one taller, you will need to have a set of twins. They have the exact same DNA, they do the exact same thing every day, all right? Even right down to number of hours they sleep. Because everything needs to be the same except one drinks milk and the other doesn't. And this drinking of milk is something that you can control. And that's the only one that you change. So what are you then measuring? That is the measured variable. So in my example, I talked about to find out if drinking milk will make you taller. So basically, in order to determine whether one is taller or not, you will look at his or her height. So the height is your measured variable. So this cannot be controlled. Okay, you have no say over this. Alright, N is what you measure, or rather is the results. Okay? So let's take a look at a question to help us better understand. So whenever you have an experimental question, the first thing you do is always to identify the change variable and the measured variable. That's very important. Okay? So Terene set up the following experiment. She placed a light sensor at different distances from the torch as shown below. So the word different tells me that this is something that is not the same, it's changed. So is this determined by Terene? Yes. So this would be your change variable. So usually I would just put CV to indicate change variable. Alright, she then recorded her results in the table below. So in the table, she actually recorded amount of light detected. So this is actually your measured variable. Okay. Now, when you are analyzing tables, right, it is very important to use arrows to help you to determine the direction of trend. So for example, in this case, it is 50, 100, 150, 200. So this is actually, when you read it this way, it is actually increasing. You will need to write the word increasing. Okay, I will show you why. Even though it's a downward arrow, this downward arrow does not denote decreasing. It tells you the direction of the trend. This, on the other hand, tells you, is it increasing or decreasing? And then you do the same for the other side. So if you take a look at it, 900, 750, 580, 350. So if you were to read it in the same way, this is not increasing, but it's actually decreasing. Right? So from here we really know the relationship. Okay? As distance x increases, amount of light detected by your light sensor actually decreases. Alright? So what is the aim of the experiment? So what we would do is we will follow this whole structure. So it is to find out if the distance x, okay, what does it say? Affects the amount of light detected by the light sensor. Okay, and over here we have our change variable and our measured variable. So this is what you need to do when you're asked to find out the aim. Now, moving on. Question 2. The table below shows the heart rate of a man as he does different activities. So once again, first step, identify measured variable and change variable. So the word different is here. This is my change variable. And then after that, heart rate is my measured variable. Okay. So if you take a look at it, ask yourself, what kind of activity are they? So you can say that it is to find out if different type of activities affect rate of heartbeat, okay, or heart rate. You can say that, but does it really translate to anything that is meaningful? Not quite, right? So if you take a closer look at this activity, you will realize that each activity here, alright, represents different intensity. So if you looked at it, it increases, right? Resting is the least intense, and then you have walking, jogging, and sprinting being the fastest. So actually, this is actually intensity of exercise, right? So in fact, what you want to find out is to find out if increasing intensity of exercise affects heart rate beats per minute. As much as possible, please use back whatever terms the question has given to you. This is to avoid any careless mistake. Alright? Because sometimes a change in word can mean very different things. Okay, so this is your change variable, this is your measured variable. Okay? Now, moving on. Okay? Next, question 3. Mr. Koh placed 5 identical fruits A, B, C, D, and E in rooms of different temperatures and measured the time taken for each fruit to split open. The results of his experiment are shown. So, what exactly can you control? Temperature. And what was being changed? Your temperature. So your temperature will be your CV, and what you are measuring will be the time that it takes to split. Okay? So your time taken to split would be your measured variable, something that you cannot control. Depends. Okay? So it will be to find out if temperature of surrounding affects time taken for fruit to split. So this is your CV and this is your MV. Now in exams, you do not need to indicate what is your CV and MV, but it's a good habit. Alright? But you have to annotate. Through annotation, it actually helps you to narrow down not only the topic that is being tested, the concept that is being tested, but as well as what is the change variable, so you know the cause and effect, which I will explain a little more. Next, we go on to reliable results. Now, this is the point that I want to differentiate for you. What are the 3 very different things? So you need to listen very attentively. Okay? Now, there are 3 things that people tend to get confused. I am doing forward teaching now, so that when I reach the other 2 types of questions, you would be less confused. Now, the three types that people often mix up would be reliable, reliability, accuracy, as well as the last one will be fair test. Okay? Now, these are the three things that students often get mixed up. They don't quite get it. Okay? So, reliability talks about how many times can you get the same results. It talks about getting similar or same results. The ability to do that. So it does not mean that your experiment is a fair test. Okay? Neither does it mean that it's accurate. It just means that you are able to get back the same results over and over again. So it's very reliable. So in fact, if you flip it in a negative sense, if someone is late 364 days out of 365 days, we can say that this person is very reliable at being late. Okay, so it doesn't mean that it's always positive. Reliable just means how often can you actually get back the same results when you repeat the experiment. Obviously, the more number of times you can get back means the more reliable it is, the more trustworthy you are likely to get back this result. Think about the vaccination for COVID. When you go for a vaccination, you want to choose one of high reliability because it shows you that time and time again you are offered protection. Accuracy has got to do with your measuring, your measured variable. What does it mean? So for example, if I ask you to measure the running track using a meter rule versus using a measuring tape. Think about this. Which is more accurate? You would say that the correct answer would be a measuring tape because it's continuous. And there are certain areas whereby it's a bit curved on the running track. So that is something that your meter rule, every time you measure 1 meter, you have to then move the whole ruler. So when you do that, you could introduce human errors. And for the curving part also, you might not be able to measure it accurately. So it's got to do with that. Another example with this, if I give you a job of measuring how fast someone can run, I give you an analog stopwatch. Analog stopwatch means it's got the clock hands. The decimal place that you can have is 0.1 only. So for example, 10.1 second. But a more accurate instrument, such as the digital stopwatch, will be able to measure up to 2 decimal places, 10.15. So the digital stopwatch is more accurate. And that's what we talk about when we talk about accuracy. How can you capture the measured variable correctly? The last one is about fair test, whereby it talks about only having one change variable. Because if you got 2 change variable, for example, if we talked about our drinking milk makes one taller example, besides just having one twin to have milk and the other not to, I actually changed their sleeping time. So maybe the twin that had milk, I got him to sleep for more hours. So when if the results come back and the twin that had drunk milk actually was taller, I cannot attribute the results at all to drinking milk, because for all you know, it is not the drinking milk, but it is actually the longer sleeping duration that allows the twin to grow taller. See? So these 3 three very distinct different questions asking about different things in the experiment. You need to understand what is the question asking for. If not, you will actually write the wrong answer. Alright? So reliable results here tells us why do we repeat the experiment? To ensure the experiment results are reliable and to reduce human errors. So how does this work? So for example, you do the experiment 3 times. Okay, you are tasked to actually get the recording of how fast somebody runs. The first time round, a fly actually came by and you got distracted. So you didn't press the stopwatch fast enough. So there's a human error. So how do we reduce the impact of that? We repeat the experiment more number of times. So if let's just say you repeat the experiment another 2 more times, and the other 2 more times you did not get interrupted by the fly, you actually stop the stopwatch the minute the person crossed the line, you take the average. So that the first one, which is error, it gets diluted. Okay? So, now this part, how do you reduce? Okay, this is a very standard answer. You repeat the experiment at least 3 times. Okay, now I want you to add in, repeat the experiment. This is very, very important, at least 3 times. Why? The more number of times you repeat, the more reliable. Okay? Because the chances of you making an error or the chances of the results being like that due to an error is reduced every single time you repeat. Okay? So next, relationship questions. What is it about? It is to identify the change variable, and the measured variable, and observe how the change variable affects the measured variable. So this is very important. So the change variable in this instance is actually known as the cause. Here, very important. And then the measured variable is actually the effect, cause and effect. This is very important because in your answer, if you get these two swapped around, your answer is wrong. So don't always assume that whatever the questions give you in that order is actually the correct order. I will show you in a while. So what kind of relationship can you have? So what should it be? It can read as, if the change variable increases or decreases, the measured variable will increase or decrease. So whether increase or decrease depend on your results. Okay? But there is actually a third one that is not here. Okay? I'm going to tell it to you right now from the start, teaching forward again. If the change variable increases or decreases, the measured variable remains constant or remains unchanged. That is the third one that is not here. Okay, to remain constant means remain unchanged. No change. Okay? So let's take a look. The table below shows the heart rate of John as he does different activities. So the type of activity here, this is actually your changed variable, your CB. And your heart rate over here would be your measured variable. Now remember, I told you, you should actually draw arrows to show you how you read. And this translates to increasing intensity, right? And your heartbeat rate actually also increases. So now, when you read, right, you know as intensity of exercise increases, so because the arrow is also the same, you know that your heart rate also increases. Okay? So you would say, as the intensity of exercise increases, the heart rate of John increases. Okay? So what are the keywords? Increases, and then this is your change variable, measured variable. Next question. What can John do to ensure that his results are reliable? Okay, the answer is very standard. He can repeat the experiment at least 3 times and take the average. Alright, this is a standard answer. Okay? Okay, next question. Question 5. This is very important. Look carefully here. The table shows Sally's breathing rate when she was cycling in a race. So you realize for this straight away, you need to identify your cause and effect. So if you're not careful, you might have identified the breathing rate as your measured variable because it came first. So your breathing rate is actually your measured variable, and your cycling speed is actually your change variable because she can control her speed. Some of you may actually argue that, oh, but she can also control her breathing by purposely don't breathe. But that's not the point, this is beside the point. If all else is natural, okay, you should see that your breathing is something that you cannot control, okay, voluntarily, especially when you are exercising. So this is your change variable, and this is your measured variable. So once again, do your arrows. It's when it's reading this way, it's actually increasing, and this way is also increasing. So you know that as cycling speed increases, breathing rate increases. So let's take a look at the question. What is the relationship between Sally's breathing rate and her cycling speed? So this is where many students will go, as her breathing rate increases, her cycling speed also increases. This is wrong. Okay, it means that as long as she breathes faster, she's cycling faster. That's not true. That means even though she's sitting down, as long as she breathes faster, she's cycling? No, right? So identify, this is actually measured and this is actually changed. So it needs to be this way. As her cycling speed increases, Sally's breathing rate increases. Okay, this and this. So this over here is your change variable. This over here is your measured variable.